Okay, thank you so much for coming back for that final parent function, our log function. Log is something you probably haven't seen before, but the best way I can describe it and is going to make the most sense to you right now as far as graphing it is that it is the reverse of an exponential. Here soon you will learn that that means inverse, but I can graph it by swapping all of my x and y values here, and that's if this has a log base of 2, just for simplicity and being able to graph some numbers. If I switch those x and y values, now I'm at 1, 0, 1, 2, excuse me, 2, 1, 4, 2, 1, half, negative 1, and so on. So I swapped the x and y values, and this is what our graph looks like. So now we have a vertical asymptote here, which means my domain is going to stay greater than 0. And my range is also never going to cross over that axis, so it's going to remain greater than 0 as well. Or, excuse me, I did that backwards. Y is going off to infinity up and down, so it is all real numbers, because it goes up and down. My x-intercept is at 1, 0, and now I no longer have a y-intercept. The maximum number of times this is going to ever cross our graph is once. As x approaches positive infinity, y is doing the same thing, approaching positive infinity. But my other boundary is no longer negative infinity. It's as x approaches 0, y is going into the negative direction, so negative infinity. It is continuous. And again, like I was saying, we have a vertical asymptote here this time at x equals 0, and this graph is not symmetrical either. So we are going to be spending time throughout the year doing a deep dive on each of these functions individually, but your responsibility right now is to be able to recognize just the parent functions and its characteristics. So if you can graph it, you should be able to do all of this if you understand what it means. So that is where we are starting out first.